3 and 4 are outside the 3 and 4 are outside the circle, so z minus 2, if we will take a point that z minus 2, that will be within the circle, and that point will be less than 1, will be less than 3, less than 4. So when you will apply the binomial series, z minus 2 will be smallest, that will be less than 1. As I have told you, you will take common the bigger term in between 1 and z minus 2. 1 is the bigger term, so take 1 as common, and here z minus 2 is bigger, so take minus 2 as the common. And then apply the binomial series 1 minus z to the power minus n. Okay, in second method you can also, this is the binomial series expansion, and in second method you can use the Taylor series expansion formula. That is, you have to find a f of z, that is f of 2, by the equation which you get by partial fraction method. This is the equation which you get by partial fraction method. Only put 2 in place of z, so minus 4 by 2 minus 3 plus 5 by 2 minus 4. Then f dash z and f dash 2, then f double dash z and f double dash and triple derivative of f of z, and put 2 in place of z. Then apply the answers to the formula of Taylor series, that f of a plus z minus a into first derivative of f of a plus z minus a by 2 the whole square by 2 factorial, double derivative of f of a plus a triple derivative of f of a into z minus a whole cube by 3 factorial. Look at this question, f of z equal to cos z. Expand in Taylor series at z equal to 5 by 4. Find f of z at pi by 4, then f dash z, that is derivative of cos z, that is minus sin z, f dash pi by 4 minus sin pi by 4, f double dash z minus sin z, derivative of sin z is cos z, minus cos z. Then double derivative of f of z at pi by 4 minus cos pi by 4, likewise you put in the formula. This is a question that sin z by z minus pi. So one trick you have to apply, put z minus pi equal to t. We get that t plus sin bracket t plus pi by t. Then by putting minus 1 by t as common, expand the series of sin t, which is t minus t cube by 3 factorial plus t 5 by 5. You have to remember this. This is a important expansion, sin t and cos t. What is cos t? 1 minus t square by 2 factorial plus t 4 by 4 factorial. Okay. Then one Laurent theorem question. Laurent theorem is applied where the f of z is not analytic at a point, but Taylor theorem is applied where f of z is analytic. Here is one question that 1 by z plus 1 into z plus 3. Apply partial fraction method here, a by z plus 1 plus b by z plus 1. Equate a plus b into z. A plus b is the coefficient of z. To here is 0 z, the coefficient of z is nothing, so a plus b equal to 0, and the constant term 3a plus b equal to 1. Solve the equation, get a and b value, then form the fraction. That will be half j by z plus 1 minus half by z plus 3. A question is given, z is in between the 3 and 1. So while taking common, you will take the bigger term common. In between z and 1, z you should take z common, and in between 3 and z you should take 3 as common. Then apply the binomial series expansion here. Here the binomial series will be placed, that is 1 plus z to the power minus n. That is the answer is 1 minus nz plus n whole into n plus 1 by 2 factorial z square minus n whole into n plus 1 whole into n plus 2 by 3 factorial z cube. In case of 1 minus z to the power minus n, these are all plus, but in case of 1 plus z to the power minus n, alternative plus minus is used. So note that. Then put in the formula and get the answer. And another question is that z is greater than 3. Always remember that take the bigger term as common. So in case of here z as common, if z is greater than 3, then z is also greater than 1. Here take z common, here take z common. Then another question that 0 greater than z plus 1 is greater than 0 but less than 2. So first you have to convert the denominator to z plus 1. Here is z plus 1 already written, and in case of z plus 3, put z plus 1 plus 2. Then take as it this is z plus 1, it is remain at it as it is, and in between z plus 1 and 2, which one is bigger? 2 is bigger, so take 2 as common. 1 by 2 whole into 1 plus z plus 1 by 2 to the power minus 1. Then put the series 1 plus z to the power minus 1, this series. These are some of the problems on calculus of residues. First, look at the formula. To find the residue at simple pole, the formula is limit z to the power a z minus a fz. And if it is in the fraction form, then make the derivative of the denominator part. Then residue at a pole of order n, you have to take that 1. This is the formula, remember this. 1 by n minus 1 factorial d to the power n minus 1 by dz to the power n minus 1 z minus a to the power n f of z. By taking derivative, put a in place of z. This formula you have to remember. Then residue at a pole z equal to a of order simple pole or of order m. M means the negative pole. There you have to take z minus a equal to t, and what the coefficient of 1 by t, that will be the residue. This is a most question at the previous year CPET, that find the residue of f of z at z equal to infinity. That will be limit z to the power infinity minus z fz. Remember this. Or if you write in 2 pi by 4 minus 1 by 2 pi fz dz integral. And another residue theorem is there. To find the residue f of z dz equal to 2 pi I into sum of the residue of the poles within the circle. Let's see some of the questions. First question is z square by z minus 1, z minus 2, z minus 3. Find the residue at 1, 2, 3 and infinity. As I have told you, for simple poles, what is the formula? Limit z tends to 1, z minus 1 fz. Then z minus 1 cancel out. In place of z put 1. Then find the answer. Then z equal to 2, find the residue. Limit z tends to 2, z minus a fz means z minus 2 fz is this, z square by z minus 1, z minus 2, z minus 3, z minus 2 cancel out. Then put 2 in place of z and get the answer. And this is a question z equal to infinity. As I have told you the formula, limit z tends to a minus z fz. So minus z fz is this. That will be minus zq. What you have to do, take z common from these three factors, and the z cube in the numerator and z cube in the denominator will cancel out, and put infinity in place of z. 1 by infinity, 1 by infinity, 2 by infinity, 3 by infinity means 0. 1 by infinity equal to 0. So 1 minus 0, 1 minus 0, 1 minus 0. In the numerator it will be 1, and the numerator it will be minus 1. In denominator it will be answer will be minus 1. Okay. Then look at this question. This question is 1 by z square plus 1 to the power cube at z equal to I. Find the residue at z equal to I. So first simplify this. Z square plus 1 equal to 0, z square equal to minus 1, z equal to plus minus I. So what are the poles? Plus I and minus I. Z plus I whole cube, z minus I whole cube. The question has asked that find the residue at z equal to I, and in I the order is 3. For 3 I have told you the formula that 1 by n minus 1 factorial. N is 3 here. 1 by 3 minus 1 factorial, 2 factorial, d to the power n minus 1, dz to the power n minus 1 means d to the power 2, dz 2, then z minus a, z minus a, the to the power order, here z minus a is I, to the power order is 3, z minus I to the power q, z minus I to the power q cancel out, and you have to find the derivative, then put I in place of z. Find the derivative is 2l by z plus I to the power 5 and put I in place of z. So here 2 and 12 cancel out, 6 divided by 2I to the power 5, 32 I to the power 5, I to the power 5 means I to the power 4 into I to the power 4 is 1 into I, so I to the power 5 is I. So why I have written this minus 3I by 16, minus 1 is I square. So if I will put in the denominator I square, then it cancel out I. So I can write this also 3 by 16I or minus 3I by 16. Okay. Then one question is here is given z by sin z. If the question is in the fraction form, I have told you the formula. Make the derivative of the denominator term and put the pole. In case of z, pole is here sin z equal to 0, so sin n pi equal to 0, z equal to n pi. So make the derivative of sin z, cos z, then put n pi in place of z. As we know from Fourier series, cos n pi equal to minus 1 to the power n. Another question is there, that is residue of z ez by z minus a to the power cube at its pole. To solve this question easily, take z minus a as t. Z minus a as t, z equal to a plus t, then put a plus t in place of z. What you get? A by tq plus t by tq, that is 1 by t square, e to the power 8 or e to the power t. You can also expand e to the power t. E to the power t equal to 1 plus t square by 2 factorial plus t cube by 3 factorial. Then solve the equation. So and know that what is the coefficient of 1 by t. Here we get the coefficient as a by 2 plus 1. As I have told you, if you take z minus a equal to t, the formula to find the residue is the coefficient of 1 by t. Look at this question. This question is given that 4 minus 3z by z into z minus 1 into z minus 2. But circle is given of radius 3 by 2. Okay, center 0 and radius 3 by 2. I have drawn a circle, center 0 and radius 3 by 2. So first find what are the poles. Poles are 0, 1 and 2. To find poles, I have told you make the denominator 0, so 0, 1, 2. So which poles are within the circle? See, 2 will be outside the circle, 0 and 1 will be inside the circle. So we will find the residue of those poles that is inside the circle. To find the residue of a simple pole, z equal to 0, what is the formula? Limit z tends to 0, z fz. So fz is this, z will cancel out, then put 0 in place of z, we get the answer. And to find the residue of at pole z equal to 1, limit z tends to 1, z minus a f z. Here a is 1, z minus 1 f z is this, z minus 1 term will cancel out, and put 1 in place of z and get the answer. Then make the sum of these two residues into 2 pi I. This is the residue theorem. Sum of two residues will be 1 into 2 pi. So answer of this integral will be 2 pi I. Okay. Then look at this question. This question is z ez e to the power 1 by z dz around a unit circle. You can expand e to the power 1 by z. I have told you 1 plus z plus z square by 2 factorial, z cube by 3 factorial. Here it is not z, it is 1 by z. So 1 plus 1 by z plus 1 by z square by 2 factorial plus 1 by z cube by 3 factorial. 3 factorial is 6. 3 factorial is 6. Then multiply z to the equation. So I have told you the coefficient of 1 by z minus a will be the residue of the simple poles. Here a is the unit around unit circle, means a is 0 around center, so z minus 0. So what is the coefficient of z? That is 1 by 2. If the question has asked find the residue at infinity, then the answer will be minus z f z. Then find minus z f z, then and coefficient of f z, that will be coefficient of f z will be 1 by z, coefficient of 1 by z, that will be minus half. Okay.